So I'm Mike Ryan, and I was a grad student in NB&B from 1977 to 1972. Craig Adler was my advisor, and now I'm a professor at the University of Texas in Austin. So my thesis work was on sexual selection and communication, and I worked on frogs, a frog called a tungura frog, and most of that work was done in Panama in association with the Smithsonian Tropical Research Institute, and an association that I've kept up until today.
Wow.
It was pretty amazing. For me personally, I couldn't have imagined a better match to my interest. I came here being interested in mating systems. I'm a herpetologist. I'm very interested in amphibians and reptiles. And I was also very interested in communication. So here was Craig Adler, one of the most prominent herpetologists in the country. Here was Steve Emlen, who had just published this, what was to become a foundational paper in the field of behavioral ecology on the evolution of mating systems. And then down the hall was Bob Kapranica and the legions of postdocs and grad students that Kapranica had, all of them trying to figure out how frogs extracted biologically salient information from the acoustic background, how they could distinguish their calls in the wild, and what was it about the brain that motivated the females to respond to calls of conspecifics versus heterospecifics. So I didn't realize it until I was here for a little while that I was just in the perfect environment to think about both brains and behavior. I came here to work on behavior, but the influence of Kapranica and his folks had me thinking immediately about the underlying neural mechanisms of sexual selection. It's something that I've continued today. And then also the coursework. I don't think it's often that grad students' careers are that defined by formal coursework, but for people in my cohort at Cornell, I think most of us were very strongly influenced by Steve Emlen's course on vertebrate social behavior, and we're also very influenced by the animal communication course that was then taught by Bob Kapranica and Ron Hoy. And I've been teaching animal communication for about 25 years at Texas, and it's really an offspring of the course that I took with Bob and Ron. Yeah, I certainly did see them together. Not everybody did, and there were these discussions about the value of studying proximate versus ultimate questions, and I think that's a false dichotomy now. I don't think we can think about behavior and treat everything that goes on inside the black box as an unknown. And if we want to understand why brains work the way they do, they have histories. And these histories are so important in determining both the sensory and the cognitive biases about ways we do things. I mean, from my perspective, I'm interested in how the brain brings about the evolution of sexual beauty. And, people have said the brain is our most important sex organ. True, but the brain has lots of other things on its mind, and a lot of the way we perceive beauty and a lot of the way the other animals perceive beauty is due to sensory biases that have evolved in other domains for other reasons. And if you're studying sexual selection just as one example, and if you don't grasp that issue, that the brain is a multifunctional, multivariate organ, then I don't see how you can really get complete and true answers to in those systems. And this is true obviously for many other fields of study, migration and orientation being a other excellent example. Well, one thing that I didn't mention about Cornell, which was very important to me, was pretty much everyone's dedication to the natural history of the organisms that they were studying. I mean, Emlen is, very well known for his mating system theory work, but he's also an outstanding ornithologist. Even Bob Kapranica, an MIT engineer, a Bell Lab engineer, he used to tell me stories about the field work that he would do with cricket frogs in New Jersey. And when he would tell me about this, you could just tell it was obvious how much Bob did enjoy, the field work. He wasn't a field biologist, but he did field work, and what a thrill that he got out of it. So that would be one thing that I would suggest. I mean, there's certainly good reasons to work with systems that match the questions that you're asking. But even in doing that, I think it's critical to become, to drill deep into the natural history of the organisms that you're working on. That's one piece of advice. And the other piece of advice would just be to keep your eyes, ears, and your mind and your brain open to things that at the time might not seem necessarily important to what you're doing. For if no other reason, a lot of us who stay in academia, we have to teach, and we don't have to teach just about our research. So we are going to have to teach about molecular genetics and genomics and neuroscience and comparative psychology. As an example, if you're teaching animal behavior, all of those topics, you have to gain some command over. So, a lot of times as grad students, you want to really focus on what you're doing. But I think there's a lot to be said of also focusing a little bit on what other people are doing.